Optoelectronic is the branch of technology that combines the use of electronics and lights. In optoelectronic, the device has a limitation in bandwidth speed, signal degradation, complexity of circuit, and has a reliability issue. So, a research was carried out in order to find a suitable method on how to perform a digital logic computing using all optical method. So, based on our research paper, basic Boolean function such as AND gate use SOA and OLM configuration in its designation. So, SOA or semiconductor optical amplifier is actually an optical amplifier that based on medium of a semiconductor gate. It operates in 1.3 micrometer or 1.5 micrometer and offers up to 30 decibel gain. So there are a lot of applications that use SOA, but SOA also has its own limitation, such as when it has a higher saturation of gain, it causes a limitation to the application. But this higher saturation of gain in SOA is beneficial for telecommunication system application as it is used in non-linear signal processing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muzaira binti Ibrahim and I will continue in introduction. The NOLM is an interferometer based on the signals loop setup including a non-linear device into its arm. A non-linear device is based on the non-linear propagation in a waveguide loop formed by connecting the output port of a conventional coupler. SOA characterization parameters were used to observe its effect on AND or gate operation. SOA and OLM has been modeled and stimulated in the OptiSystem environment. Optical data plus and optical control plus are generated by using two different CW laser sources at wavelength 1542 nanometer and 155 nanometer. After done with the normal gate light and or the project will proceed with complex logic gate such as the double Freeman and Toffoli logic gate operation.
Hi, I'm going to present the objectives of this project, which is to analyze and characterize the semiconductor optical amplifier used in semiconductor optical amplifier nonlinear optic loop mirror. Second, this project is to observe the effect on an operation when varying semiconductor optical amplifiers parameters. That is, to perform digital logic computation with an all-optical method, and lastly, to achieve high-speed operation.
Hi, Assalamualaikum. My name is Farisha binti Muhammad and I'll be presenting about the literature review. So basically this chapter is about a basic understanding of characterization of OR logic gate based on SOA and OLM, as can refer in the reference number 5, and the design of all reversible optical logic gate, as can refer in the reference number 2.
So, this is the operation principles. The configuration of optical OR gate in the study is shown in figure 1. It consists of beam section PBS and two SOA and OLM. At first, the two entrant X and Z were paired with a beam combiner PBS and passed through the polarizing beam splitter, which separate the light into two vertically polarized components, D1 and D2. The SOA and OLM loops includes all components. Both SOA and OLM's reflected outputs were combined with beam combiner to achieve the final output. It is called null, no light. When there is no light, it is taken as null, which means no light. Meanwhile, vertically polarized light is taken as logical state 1 and the presence of horizontally polarized light act as logical state.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nadia binti Awang and I will continue for the literature review. Okay, for the literature review, I will explain about the SA categorization for n logic operation on SOA based on OLM. Okay, the characterization of SOA is performed through accumulate an analysis of various parameters that affect the performance of in SOA and OLM based logic operation. Okay, in the other article, the researchers has find the revolution to overcome the issue of limitation current optoelectronic devices such as bandwidth, speed, signal degradation, additional conversion delay, complexity of circuit and reliability. Okay, so the SOA calculation for n logic operation on SOA based on OLM, which is first is SOA current gain capacity. Okay, the SOA is initially biased with low current and gradually increase to maximum operation current of the SOA. In the other words, the gain is gradually increased with the SOA bias current. The next is wavelength gain capacity, where the SOA and OLM performance is slightly less affected by various input wavelength in the range of 1539 nanometer to 1560 nanometer. Okay, third is SOA gain saturation. Okay, for this characterization, the gain start to decrease exponentially below the upper limit, and the saturation output power is estimated around 10 dBm. Okay, lastly is SOA recovery time. The recovery time is decreased with the increasing of SOA inject current. This is due to the higher population inversion at large inject current. Okay, that's all from me. Thank you.
Hello. So for the methodology, the simulation of this mini project is done using the OptiSystem software. The circuit that are designed in this software are the Feynman gate, the double Feynman gate, and the Toffoli gate. So as for the Feynman gate, is as shown. The Feynman gate has two inputs. As for this diagram, it shows that the inputs are A and B, and the outputs are P and Q, whereas P is equals to A and Q is A plus B. And these are the truth table for the Feynman gate. You can see that from 0 input and 0, 0A, 0B will give us the output for P0 and Q0, and as follows. As for the double Feynman gate, it has 3 inputs and 3 outputs. The inputs are shown as which is A, B and C. The outputs are P, Q and R, whereas P is equals A, Q is equals A plus B, and R is A plus C. And these truth tables are the results of the based on the inputs. Thank you.
Hi, Assalamualaikum. My name is Muhammad Fida Birazwan. I will talk about methodology which continues from Ismail part. Next is double Feynman gate. As we can see from the block diagram of double Feynman gate has 3 input and 3 output. We can see that output P is equal to input A, output Q is equal to input A exclusive OR input B, and output R is equal to input A exclusive OR input C. The double Feynman gate is a derivation of Feynman gate, as outputs in the double Feynman gate are exactly the same as Feynman gate with the addition of input C and output R as expression. Next gate is about Toffoli gate. It also has 3 input and also a 3 output. From the output, as we can see, output P is equal to input A, output Q is equal to input B, and output R is equal to input AB exclusive OR input C. The Toffoli gate is also a derivation of Feynman gate, but with the addition of AND function between inputs A and B before going through exclusive OR with input C. Next is about construction of circuits in OptiSystem. As we can see in the slide, the circuit showed is design circuit using SOA norm configuration. From the circuit, we can see that there are 2 input units which are A and B, a clock, and 2 output units which are P and Q. Variation of injection current, time delay, and input power were simulated and compared in order to obtain an optimal output, which is similar to Feynman gate truth table. After optimal output was achieved on Feynman gate, circuit was derived to produce double Feynman gate and Toffoli gates. Similarly, variation of injection current, time delay, and input power were simulated and compared in order to obtain an optimal output, which is similar to the truth table of double Feynman and Toffoli gates.
My name is Chian Mao. I will continue to present the result for our team project. So the result will be explaining in detail which the function of Feynman logic gate, double Feynman logic gate, and Toffoli logic gate by using SOA based optical circuit. So this is the optical schematic diagram for Feynman gate. So as you can see, there are 2 outputs for our Feynman gate design, and the parameter of the Feynman circuit is set to 8 power dBm, 0.135 nanosecond, and 0.16 ampere with 10 gigabit per second bit rate. So when the parameter is set to those configurations, we got output P and output Q, which I rate this as 0011, and output Q is 0110. How to determine either 0 or 1 is depending on the power. If the power is exceed 100 milliwatt, so we assume it as 1. If lower than 100 milliwatt, we assume it is 0. So the expected output is 0011 at output P and 0110 at output Q, which is totally compatible with the actual result. Next is double Feynman gate. So for double Feynman gate, we have 3 outputs, which we set it as PQR. So these are the parameters we set in the configuration. So the important parameter in this optical schematic is the power, bit rate, and the time delay, and the current. These 4 is the most important parameter which could affect the output. For the output, not only Toffoli or Feynman or double Feynman, but all the optical circuit will be affected. From here, we rate it as the output P. This one is 0, 0, 0, 4, 0, and 4, 1 for output P. For output Q is 0, 0, 1, 1, 1, 1, 0, 0. For output R is 0, 1, 0, 1. 1010. So if compare with the actual, compare between the expected and the actual result, yeah, we can see that the hypothesis and the result are matched. So the result for diamond ferment is success, and the last one is Toffoli gate. So Toffoli gate also has 3 output, which is PQR. So the parameters same. The most important is the power, time delay, current, and the bit rate. So from output P, we can see that the output P is 00001111, and output Q is 00110011. So for output R is 0101 0110. So which fit with the actual result and expected result. Okay, that's all from me. Thank you.
Hello, my name is Fu Yufeng. My matrix number is 1711811619, and today I'll be discussing about the discussions of this mini project. So as we have shown in the methodology and results, it is hard to obtain the correct parameters to produce the expected results of the truth table of logic gates. That is why we have gone through the trial and error process to find out which parameters are optimized to reproduce the truth table. The parameters that we have modified are bitrate, delay, and power. So the bitrate, we have modified it to 10 gigabits per second, delay to 0.135 nanoseconds, and power to 8 dBm. So as shown in this table, we have tried to modify it to 20 gigabits per second and 40 gigabits per second. So this causes the frequency to increase, making the graph more compact in the same area of graph. But this produces a problem which results in the output graph does not match with the expected results. As you can see from the output P and Q, it is completely different from the truth table. That is why we have settled with 10 gigabits per second, which is optimal for the Feynman gate. Next, we tried modifying the time delay. We tried doing it with 0.1 nanosecond, 0.02 nanosecond, and the results are that they are splits in the waveform. So this is not optimal for output signals because it creates it's confusing to know which of the wave peaks is our output signal. Hence we settled with 0.013 0.135 nanoseconds. So next we have modified the input power at the pulse generator. The results are that it can increase the amplitude of the signal. So meaning initially the output signal might be 10 milliwatts, 20 milliwatts. So by modifying the input power, we can reach to 100 milliwatts, which is more prominent. And because this process, the ones and zeros are more prominent. As you can see in the table, the ones become even more prominent than the zeros, while the zeros remain almost the same as without modifying the input power. That is why this is good for our output results in identifying which can be considered 1 and which can be considered 0 in the truth table. That is all for me. Thank you.
As a conclusion, various parameters into different type of circuit in OptiSystem will get various results, and the correct parameter need to obtain to get optimal result.
Assalamualaikum and a very good morning to Dr. Samsuri and friends. My name is Muhammad Amirul Saini, and I will continue what Amira said about the conclusions. Number 3, the distortion signal interference will occur when the frequency is increased due to bit rate configurations. Number 4, when the amplitude is increased, the signal power is also increased. Number 5, the last one, the interference signal occur when the right shifted signal and left shifted signal that combine together to become one. That's what interference wave will occur. I hope that is all for today. That is all for me, and thank you very much.